Hello, I am recording this video for my Earth Science and Astronomy class. This is Nathan. So what I'm going to talk to you about today is I'm going to talk to you about the solar system, or at least part of the solar system. I'm going to talk to you about the sun, the moon, and the earth. So here you see I have a model of the earth, it's a small globe. So when I think of a model, I think of something that it represents the real thing, but is not exactly like the real thing. So this is like the Earth, but it's not exactly the Earth, right? It's much smaller, it's plastic. We can say a lot of things about how this is not like the Earth, but this is also in many ways like the Earth. In fact, if you look closely, you can see North America on this globe. And actually, a little bit later in this video, I'm going to be referencing North America because we live in Missouri, which is part of North America. So let me just put a big red sticker on North America. We'll be using this sticker later. So just kind of think of this like as a "you are here" sticker, okay? So there you are. Just for right now, I want you to think about what it is that you see in the sky and when you see it in the sky. So we know in the daytime we see the sun, right? I mean, that's kind of what makes the daytime. Is the sun up? Yes, then it's day. Is the sun down? Yes, then it's night, right? So we see the sun travel across the sky, which kind of makes it look like the sun is going around the earth. And if you look closely, you may also see other things that move around the sky. And we'll talk about those things in a second. So let's talk about some of the terminology that you guys are learning today. And my face is not red because because I'm sunburned or because I've been working. It's because I'm hiding the sun from you guys. So here's our beautiful sun, and actually, here's the moon right there. So, like I said, we're talking about the solar system. So the solar system is everything that moves around the sun. So again, this is a model of the sun, and actually compared to if this was the true size of the sun, it would be hard to capture the Earth on video because the Earth would be so small. The sun is huge. In fact, it's so huge that its gravitational influence pulls in a lot of things. We have the Earth, we have 7 other planets that go around the sun. We have asteroids and a whole bunch of space dust and space junk that are just floating around, going around the sun. So I don't have all of that. The only thing in this model is the Earth and the moon. The reason that this model only has 3 things is because this is just here to demonstrate why we see what we see in the sky. So one of the terms you guys are going to learn about today is revolution. So when I say that something is in a revolution, that means it goes around something. So for example, the Earth is in a revolution around the sun. So if I turn my model, the Earth is going around the sun, or I can say the Earth is revolving about the sun. And if you guys notice, we also have a second revolution. That's the revolution of the moon around the Earth. So the Earth is going around the sun, and the moon is going around the Earth. If we time these revolutions, it takes a little bit more than a year for the Earth to go around the sun. Actually, that's how we time our years, is that the Earth is going around the sun that takes 365 and 1/4 days. And it takes a little bit less than a month for the moon to go around the Earth. In fact, that's how we get our word month. Month kind of sounds like moon, and that's how we used to measure months. We used to measure months by how long it takes the moon to go around the Earth. But I said it takes a little bit less than a month for the moon to go around the Earth, so it's not exact. But that's why we divided our year into 12 pieces, into 12 months. So, got 2 revolutions right now, the Earth going around the sun and the moon going around the Earth. You good? Okay, so the other terminology you guys are gonna learn about today is rotation. A rotation is when something spins. So here we got the Earth revolving around the sun. But now let me get, but if you might have noticed, the Earth is also spinning. So it takes a little bit more than a day, right? It's pretty close to 24 hours, one day for the Earth to spin around one time. So right here, let me see if I can make this face you guys. Yeah, there we go. So right now, here's our little red sticker. You are here, remember? Now it's facing the sun, so if you lived here, it would be daytime. And if I shift it slightly over, now it's nighttime. And the time takes for me to go from one day to the next day, sunrise to sunrise, is 24 hours. So this rotation accounts for our day-night cycle. It looks like the sun's going around the Earth, but really it's just the Earth spinning. It's just the fact that we're facing the sun at one point and then we face away from the sun. That's how we get the day-night cycle. The moon is also rotating. So the moon's rotation is really interesting. Let me show you why. Because, so I put a sticker on the Earth already. I'm gonna put a sticker on the side of the moon that is facing the Earth right now. So right now, this side of the moon is facing the Earth. So let's kind of, I'm gonna go this way. Let's see where that sticker ends up if I turn it. So that sticker is still facing the Earth. And if I turn it again, that sticker is still facing the Earth. So the moon's revolution and rotation are equal lengths, at least as seen from the Earth, which means that this is called a tidal lock. All that it really means, though, is that the same side of the moon always faces the Earth. In fact, if you go out at night, especially when you see a full moon, the moon always looks the same. It's not like the Earth. It's not like looking at the Earth where you can look at the Earth from lots of different angles. And you can see Asia, Europe, Africa, and oceans. But the face of the moon always looks the same, and that's because the same side of the moon is always facing us. You might hear some people talk about the dark side of the moon. Well, there really is no dark side of the moon because the moon has day and night just like the Earth. But really, it'd be more accurate to say talk about the mysterious far side of the moon, because at least from the Earth's point of view, we can't see the other side of the moon. We can only see one side. So that's kind of the basics of rotation and revolution. The Earth is rotating, the moon is rotating, the Earth is revolving in a revolution around the sun that takes about 1 year. And the moon is revolving around the Earth, remember, a little bit less than a month. One interesting thing is, if you think about, I've already talked about, when you see the sun. You see the sun during the daytime, right? But when do you see the moon? So sometimes we see the moon at night. In fact, that's how we associate the moon, because that's the easiest time to see the moon. But you see the moon sometimes during the day, right? Sometimes you see like maybe a crescent moon in the sky during the daytime, or maybe like see a half moon or a quarter moon in the sky as well. And then, do you think that there are ever nights where you don't see the moon? And I challenge you to think about that, because there are nights where you don't see the moon. So let's go to the "You Are Here" sticker. So here we are right here, and if you notice, I just spun the Earth, and where's the moon? Well, it's behind the Earth, right? So if you lived on this side of the Earth, you couldn't see the moon. Now, it's daytime right now. Let's see if we can find a night where you can't see the moon. Actually, I just had to turn it a little bit. So I know you guys can't see it, but here's the "You Are Here" sticker. Here's the moon. So there are some nights where you can't see the moon. There are also some days where you can't see the moon. It just depends on where the moon is in its orbit. And this also affects the lunar phases, which is why the moon takes on different shapes. Talk about those later. But I just want you to realize that because the Earth is constantly rotating, all these things are going in and out of view, and not always at the same time. So remember, "You Are Here" sticker right here. We can see the sun, but not the moon. Sometimes we can see that moon, but we can't see the sun. That's why we might have a bright night. Might have a bright night of moonlight one night. One other thing that's not on this model that's going to be important for my astronomy class is that is just the night sky in general, or stars. So if you could pretend for a second that my wall is the night sky, I could have painted stars all over my room, and because the Earth is rotating and also revolving around the sun, our stars change. And just like the moon rises and sets and the sun rises and sets, stars also have times where they rise and set. And that just has everything to do with where the earth is facing and is the sun going to block the stars from our view. So that's something that we're going to be talking about. One thing I want you guys to do today, your assignment today, which I'm going to explain on your agenda, is to make your own model of the earth, moon, and the sun. So I'm not asking you to make a mechanical wonder like this thing right here, but make some sort of model. You can do a sketch on paper, or make a video moving balls or something around. I have my own model that you guys can click on and watch on today's agenda. So make a model of the sun, the moon, and the earth. I want you guys to draw the sun, I say draw, but make a model of the sun, the earth, and the moon, but also model the orbits. Show me that you can tell me what orbits what. Show me how long it takes for the earth to go around the sun, how long it takes for the moon to go around the earth, and how long it takes for the earth to spin. Yeah, if you have any questions about that, please let me know. I hope this helped you understand the basics of what we see in the daytime sky and the nighttime sky. Any questions at all, please reach out to me. Thanks for joining me, guys. Bye.